Hi, welcome to my channel, Algebraically. Today I'm going to go over the inverse functions using the horizontal line test, using the vertical line test, one-to-one functions, and how to find the inverse function. Let's get into it. A function is a relation in which each possible input value leads to exactly one output value. The input values make up the domain, and the output values make up the range. We learn from graphs and images, so I have enough examples with images for you. This is inputs and outputs, as you could see. This is a function. Every input has exactly one output. This is clearly a function. Not only that, we could find the inverse by clearly switching the arrows back, which is later on we're going to discuss as one-to-one function. That's a function. Now this one is not a function because Q has two outputs, and we call it not a function. Here's a different way of looking at relations between x's and y's, or inputs and outputs. Deciding if this is a function, let's take a look at it as a mapping. Clearly this is a mapping that is clear. Every input has exactly one output, so it's a function. Here's another example. It doesn't have to go straight like -1 to -1 and 1 to 1 and so on. Here's another view of what's going on. So that is clearly a function. Here's another one. Notice that if you pay enough attention, 2 is going to 5 and 15 is going to 8. That is totally fine. But look in green. I have in green 7 is going to 11 and 7 is going to 9. 7 is going to 11 and 7 is going to 9. Different ways of looking at it. 7 is going to two numbers, has two outputs. So what we say, it's not a function. So in other words, sometimes students, they go like, so x cannot repeat, like when it's Celeste. Yes, x cannot repeat. And this is an example why. If it repeats, it happens that it has two outputs. Unless if they want to make it tricky for you, they write 7-11 here and they write 7-11 here. That's kind of tricky. Let's look at the table. The inputs are x, which is 5, 10, 15, and the outputs are 3, 8, 8. Now, 10 is going to 8 and 15 is going to 8, but that's totally fine. We call it not one-to-one. It's a function because 10 has exactly one output and 15 has exactly one output. So it is a function. Here's another example. In this case, the 10 repeats and it has two different outputs. That means it's not a function. Now, when you talk about inverse functions, domain is your range and your range is your domain, and you're gonna take it back, in other words, from your outputs back to your inputs. So if this is a function called x and its output called f of x, 2 is going to 4, and you want to go from 4 back to 2, so your 4 is your input to start with, and 2 is your output, it's another function, x and g of x. 5 takes you to 12. Here, 12 takes you to 5. The mapping here, or the picture, shows a lot. The domain of f, the range of f. And you're going this way. Now, going backwards, that's called f inverse. We write -1 on top. We call it, or we read it as f inverse of x. So the range of f becomes the domain of f inverse, because you start here and you go back here, and the domain of f becomes the range of f inverse. Here's a table to exercise how do you go forward using f and how do you go backwards using f inverse. So this is x and this is f of x. Those are my inputs and those are my outputs. To evaluate f of 3 is 53. Solve f of x equals 1. The output is 1. Looking down here for 1, I see it here. So that should be coming from 2. All right. So f of 3 is 53. And if f of x is 1, if the output is 1, x should be 2. Find and interpret the f of f of 60 and f inverse of 60. This one has units, as you can see. It's not x and y, it's t as minutes, time in minutes, and f of t as miles, distance. Looking at 60, it's taking you to 50. It's right here. So f of 60 is 50. But what does it mean? The interpretation of this is that it takes 60 minutes to drive 50 miles. That's the meaning of it. Let's go for the other one. Well, if the f inverse of 60, that means we are going back from this back to the input. This is f inverse, going backward. So 60 is my input now. The output should be 70, and we read it this way. F inverse of 60 is 70. The interpretation of this is that to drive 60 miles, it took 70 minutes. Okay, let's now talk about the inverse functions and more detail about inverse functions and how to find them. If f of x equals x plus 2, so going forward, all what it says here, you're going to be adding 2. So if I give you 5, you're going to give me 7. If I give you 10, you're going to give me 12. If I give you 5, you add 2 to it, you give me 7. Under the function f, 5 will take you to 7. Speaking the other way around, backwards, g of x equals x minus 2. You subtract 7, you reduce it by, you subtract 2 and you reduce it by 2. So 7 minus 2 will take you back to 5. That means in green here, the g function, which is written as x minus 2, will take you back from 7 to 5. And clearly, this increases the values by 2, this decreases the values by 2, so they are inverse mode of each other. So we call them inverse functions. What about if there is more steps involved, like 3x plus 2? You multiply, you triple the amounts, and you then increase it by 2. To do it, you could think about, the steps backwards, because it's exactly thinking backwards. Like, in driving, if you go north 5 miles and east 2 miles, going backwards, you have to go west 2 miles and south 3 miles next. So it's kind of the same process if you think about it this way. But let's just do it with steps and make it clear with math. F of 7 equals 3 times 7 plus 2. 21 plus 2, which is 23. So under the function f, I'm doing 2 steps. I'm multiplying by 3. 7 takes me to 21. Then I'm going to add 2. See, I added 2 after I multiplied. I get 23. Going backwards, 23, subtract 2. Because you were adding 2, you're going to take it back step by step. So the last step in the first equation will be the first step in the inverse mode. Subtract 2, I get 21. Now instead of multiplying by 3, we're going to divide by 3. You get 7. If you like concepts, if you like shortcuts, that's how it works. So g of x equals x minus 2. You subtract 2 first. Then wherever you get out of that, the whole thing, you divide it by 3 and you should be fine. Let's do it in steps. Not every single problem is going to be that clear, and not every single student will like this method, which is, you might call it shortcut. In steps, if f of x equals 3x plus 2, first step, you're going to have to call it y. It's easier to call it y instead of f of x. So it's y equals 3x plus 2. Step 2, switch x and y, because in the inverse mode, your x is your y is your x, your input is your output is your input, and so on and so on. So go ahead and switch x and y. Y was here, now it's in place of x. And what took the place of y here is x. You switch them. Step number 3, solve for the new y. subtract 2 from both sides. I get x minus 2 on the left. This cancels and I get 3y. Divide both sides by 3. And I get y equals x minus 2 over 3. Alright. Step number 4. Call it g of x or f inverse. G of x equals x minus 2 over 3. Now g of x is the inverse function of f of x, and we write it as f inverse to the power negative 1. We read it as f inverse of f. Okay, let's go deep into this problem with the inverse concept. So f of x equals 3x plus 2, and g of x equals x minus 2 over 3. F of g of x, the composition of f after g of x. So if you apply the first function and then you apply the second one, which we know from the previous slides that it's the inverse, it's going to take you back. So if, let's say, 10 takes you to 20, and 20 in the inverse mode takes you back to 10, so you're going to go like 10 to 20, then back to 10. So you're going to start with the same x and go back to the same x. In other words, you start x and you end up with x. Differently, we call it f of g of x. Instead of g of x, I'm going to write what we agree on, x minus 2 over 3. Now we're going to apply f, but f says multiply by 3, divide by, add 2 after. So multiply by 3, add 2, the 3 cancels, and I get x minus 2 plus 2. Now we don't need the parentheses here, and we're going to cancel the 2's, and we end up with x, as expected. Because if this is the inverse of this, and this is the inverse of this, you're going to have to start from x, you end up with back to x. So f of g of x equals x. Let's try the other way around. G after f, or g of f of x. First, we're going to apply f of x inside, and f of x is 3x plus 2. Now we're going to apply g. G says whatever I give you, deduct 2 from it and divide the whole thing by 3. Subtract 2 from it and divide by 3 the whole thing. We don't need the parentheses now. We cancel the 2's. I get 3x over 3. Simplify, and I get x. So g of f of x is also x. Okay, that supports that a function f and a function g of this right here as an example, they're inverse of each other. To find out if you are given two functions like this, if they are inverse of each other, you don't want to try with numbers. That's not how to show it. You want to test it this way or this way. Either one will work. You don't have to pick both. One of them will do. How to? Given two functions f of x and g of x, test whether the functions are inverses of each other. This is like notes about what I was talking just like seconds ago. Determine whether f of g of x equals x and g of f of x equals x. Just like the way we did it in the previous example. If either statement is true, then both are true. We say g is f inverse, and we say f is g inverse. If either statement is false, then both are false. Alright? Now let's talk about more detail about functions, vertical line test, and how can we invert functions knowing the main condition from graphs. Vertical line test. The vertical line test can be used to determine whether a graph represents a function. If you can draw any vertical line that intersects a graph more than once, then the graph does not define a function. Because a function has only one output value for each input value. Vertical line test. This vertical line is a sample. I could graph it anywhere I want, and it's not going to cross the graph more than once. So this is a function. This is not a function. The vertical line crosses it more than once. This is not a function. For a function f to have an inverse function called f inverse, it has to be one-to-one function. Otherwise, you need to restrict the domain to make it one-to-one. What's one-to-one? Sometimes we write it like 1-1 in short. A function is one-to-one if no two elements in the domain of f correspond to the same element in the range of f. In other words, every output has it's related to one input. We're not having two inputs sharing the same output. Let's make it more detailed with graphs and examples. In other words, each x in the domain has exactly one image in the range, and no y in the range is the image of more than one x in the domain. So it's like back and forth. Every input has exactly one output. That's like a function definition. Every output, every y, is an output for a single input that comes from a single input, not relates to two inputs or more. A one-to-one function is a function in which each output value corresponds to exactly one input value. So it's like the definition of functions, but backwards. There are no repeated x or y functions to have it a function and to have it an inverse function or one-to-one function. Once we have determined that the graph defines a function, an easy way to determine if it is one-to-one function is to use the horizontal line test. Through a horizontal line test or horizontal lines through the graph, if any horizontal line intersects a graph more than once, then the graph does not represent a one-to-one function. Let's look at some examples and some graphs. This is definitely not a one-to-one function, so we can't invert this function. This is one-to-one and it's a function, and we could clearly inverse the hours and call it an inverse function. This is exactly what one-to-one talks about. Every output, every y, comes from exactly one input. This is coming or relates to two different inputs, so that's not a one-to-one function. If you want to inverse this one, you're going to have a problem. Switching the arrows, 9 will have two outputs going backwards. That becomes not a function. So a one-to-one function means like 5 is going to 7, 7 is going to 5. There is nothing like here 9 coming from 2. There is nothing called 2. It's one-to-one both ways, going forward and going backwards. We did similar examples, but here's more as a graph. Find g of 3. Well, g of 3 is going to go up here and it's going to relate to 1. G inverse of 3. So inverse means your input is right here. That's my input for this function. So I have to be here, go to the graph and go down. Let's take a look. So the first one will give me 1, and the second one is the output 3 came from 5. So g of 3 is 1, and g inverse of 3 is 5. One more time, g of 3 is 1, and g inverse of 3 is 5. F of 2 is question mark, and solve for f of x equals 4. Well, f of 2 is 1, But when the output is 4, this is 4, I see two locations, one to the right and one to my left. Let's take a look. F of 2 is 1. That's the answer for the first part. And for the second part, if your output is 4, your y value is 4, I could see that x could be 3 and x could be -1. So f of x equals 4, we have x equals -1, and we also have x equals 3, two outputs. That's speaking inverse mode. That's kind of like, you know, the output, you want to go back to the input. That's the horizontal line test. So if you want to switch this one, it's going to be a problem. 3 gives you 4 and -1 gives you 4. Switching it back, 4 we will be going to -1 and 3, which is not a function. So this is not a one-to-one function. Quadratic functions are like this. We know that 2 takes me to 4, -2 takes me to 4, as you could see. Those are not one-to-one functions. Now to find the inverse, graphically, we reflect the function around or about y equals x, and that's how we find the inverse. Let me show you what happens if you have a horizontal line right here crossing at 4 two places, which is called a horizontal line test, telling me that this graph is not one-to-one function and I cannot find the inverse. If you do that and you invert or reflect about y equals x, this is what happens. So this is my y equals x to the second, and if you want to reflect about y equals x, this portion right here becomes like this, and this portion right here becomes like this. That's the reflection. But notice that -2, 4, 2, 4 are here written as 4, -2, 4, 2. They're switched. That's called inverse mode. Now I have a problem with the green graph with the line that is vertical crossing it more than once. That tells me that this is not a function. So to find the inverse function of a second degree, we need to drop this down and keep this. We need to restrict the domain and invert this one only. This will have the green one on top, which is defined or known as y equals square root of x. Here's more details. The function y equals x to the second does not pass the horizontal line test. We talked about that more than once. Because a horizontal line can be drawn that intersects the graph at more than one point, so the function is not one-to-one. We could see it right here at 4. If you restrict the domain, you drop this and you keep this. Now you have f of x. Look at this right here. The square root function, which is in green, is the inverse of the power function f of x equals x to the second when the domain is restricted to be x greater than or equal to 0. So if you just keep the 1 here and you take the negative portion, like when x less than 0, you take it out, you could invert this because it doesn't contradict or it passes through the horizontal line test. And when you reflect about y equals x, this is a reflection, this is x to the second, this is square root of x, which makes more sense. 4 takes me to 2, here 2 takes me to 4, and everything is fine both ways. Now x cubed is being called odd function, not even, and it is one-to-one function because horizontal line test passes. To reflect about y equals x, you're gonna have to switch it this way. This is gonna go like that on top, and this is gonna go like this. But there is another way to say it. Let's take a look. Actually, there is more slides for that in the coming section. Sticking to the slides right here, Here's more examples about one-to-one functions and functions that do have inverse. 1 over x is called the reciprocal, and it is one-to-one function. As you can see, I could invert it. One over x to the second is not one-to-one. Clearly, you could see right here, 2 points right here through a horizontal line. You could see that 0.25 coming from 2 and 0.25 is coming from -2. That's not one-to-one. Square root of x is one-to-one function. Cubic root, this is what I was talking about earlier, but I stopped. Cubic root is the inverse of x to the third. So if you reflect it about y equals x, that's what you get. And it is one-to-one function, and the inverse is x cubed. Quadratic, we talked about that more than once. We have to restrict the domain. Quadratic function with domain restricted to be from 0 to infinity, including 0, will be one-to-one after you restrict the domain. And this is how you find the inverse, which is square root of x. In general, clearly it doesn't have to cross the line of reflection. If this is a function, the inverse is, in green right here, f inverse of x. That shows the reflection about the identity line, which is y equals x. Cubic is one-to-one, and we talked about that more than once, and that's its inverse right after that, showing you the first one. So this one is cubic reflected about y equals x. I have them separate, not on the same graph, and that would be the inverse. That should do it for this one. It's about 28 minutes. Thank you for watching. Don't forget to hit the like button, subscribe to see some more, and I'll see you in the next one.